Greetings, students. We're going to discuss practice test 4.1. Question 1. These angles will be congruent on a parallelogram. So I'll set 13x minus 9 equal to 108. Remember, if they're above each other, they would be supplementary because they'd be consecutive. So I'll add 9 to 108 and I'll get 117. And I'll divide that by 13 to get my finished answer, which is 9. Next question is a trapezoid. So this is the mid-segment of a trapezoid. It will be equal to the average of the bases on said trapezoid. So 11x plus 1 is going to equal half of 30 plus 16. Well, 30 plus 16 is 46, so it's going to equal 23. That 23 is halfway between 30 and 16, because this mid-segment is halfway between 30 and 16 on the trapezoid. So subtracting 1 from 23, we get 22. Dividing by 11, we get 2. Question 3, Pythagorean theorem. We're going to take 8.2 squared. We're going to take 7.2, 7 and 2/10 squared. We were looking for hypotenuse, so we're adding, because we're looking for the hypotenuse. If I was looking for one of the shorter sides, or our leg in other words, I would be subtracting. So 8 and 2/10 squared plus 7 and 2/10 squared. It's 119 and 8 hundredths. I'm going to square root this answer to get my finished length, which is about 10 and 9/10. Next one, we're looking for an angle, so we're going to use arc, sine, cosine, or tangent. So here I've got this angle here. I don't have the hypotenuse. I've got opposite adjacent, so I'm using TOA. Tangent is opposite divided by adjacent. So we're going to do, this angle is equal to the arc tangent of 30 over 18. I use tangent again because we have opposite adjacent. We don't have the hypotenuse. So the arc tangent of 30 divided by 18 is approximately, here's the issue with my calculator, this is not a degree measurement. This is a radian measurement. So to make this degrees, I'm going to go into mode, go in here and change to degrees. How did I know it's not degrees? Because it was so small, the answer. There's the degree measurement. 59 degrees. That's going to be important on this question and on question 6 and 7. Oh, sorry, this question and question 7, not 6. Alright, question 5, cosine. We're looking at ca. So the adjacent to A is 27 and the hypotenuse is 45. Here we're looking at the unit triangle with the 45 degree, because it's got the 45 up there. So I'm looking on the board there and I'm looking at that triangle, and it has a 1, and a square root of 2. This triangle is 3 times as big. So when I times this one by 3, it becomes this one. That means n is 3, and m is 3 times the square root of 2. Alright, here we're looking at sine, opposite hypotenuse. We're looking at so. So the sine of 35 degrees will equal x divided by 18. So x is going to equal 18 times the sine of 35. 18 times the sine of 35 is going to yield 10 and 3/10. Alright, so similar triangles here. X and 9. X is the hypotenuse, 9 is the short leg, is equal to, now X is the short leg. The hypotenuse, however, is the whole length. That whole length is 25. There's my setup. X times X is X squared. 9 times 9 is 9 times 25 is 225. And the square root of 225 is 15. X is 15. Alright, the symmetry. We're talking about what we talked about on Thursday, what we're talking about today. So line, point, and rotational symmetry. So line symmetry is when you can cut a figure in half evenly and it can fold on top of itself. So if I take the letter M, and I draw a line through the middle, I can fold it left to right. So this does have line symmetry, because I can fold it left to right. Point symmetry and rotational symmetry. Point symmetry, when we define it, is when you can turn the figure upside down. So, like the letter N, when you can turn it upside down, then it becomes the same letter. And rotational symmetry is when you can turn it upside down or another angle. So, these two types of symmetry, point and rotational, are actually very similar. Point is a type of rotational symmetry, the rotation being 180, whereas rotational can be another angle besides 180, like 30 or 40 or 50 or 60 or 90 or something like that. So the letter M, we can't turn it upside down, because if you turn it upside down it becomes W. So it doesn't have point symmetry, because the letter M, when you turn it upside down, becomes W. Neither does it have rotational, because you have to spin it all the way around before it becomes the same letter again. So I can do that with the paper here. You see I'm turning it around, there it's kind of like an E. Upside down it's like a W. And then here it's not even a letter anymore when I turn it 270. So it only has line symmetry, or you can fold it in half. The letter S. So here's the letter S. Some of you are probably thinking, well, I can fold this one in half too, through the middle. But if you fold it through the middle, it doesn't fold on top of itself, because the curves don't match. You see the ends don't match together. So it doesn't have line symmetry. It does, however, have point symmetry, because if I turn it upside down, if we drew a nice S, it's the same upside down as it is right side up. So it does have point symmetry. So I'm going to say this one has. And the rotational symmetry would be 180, which is point symmetry. So again, point is a type of rotational. So if we say point, we can say rotational, the rotation being 180. Those are kind of synonyms. So I wouldn't mind if you put rotational as well here, because it could be both. Anyway, so that one's a new question on the test this week. On the back, these, the only new one here is the dilation. The rest of these we did last week. So reflection on the X, you're going to fold everything up. Well, E is going to stay the same. D is going to become 1, 2, 3, 4, up. And F is going to become 3, up. There's F, there's D. Again, this is going to be visual, because it's so much easier for me to grade a picture than it is for me to grade all the numbers individually. Alright, so here we're going to take 3 to X, add 3 to X, 1, 2, 3, and take 7 away from Y. 2, 3, 4, 5, 6, 7. So there's K. Remember, this is a rigid motion, because we're not doing dilations here until number 14. So this is going to be the same amount of spacing. So 2 to get to letter L, and then 1 more to get to letter M. So once I've placed K, I can place L and M pretty easily. I can also count them 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, if I get confused. Alright, The rotation 180, turning the paper upside down, puts C at -1, -1. Left one, down one, there's C. Puts E at -3, -1. Left 3, down 1. And puts D at down 5. Down at the bottom of the grid. So there's my image. Rotated 180. I recommend that you actually do the paper spinning, because some of you last week did not get the right images. You had trouble with this, some of you. Alright, dilation, double the point. So this one, F, D, E, F. This F, it's at -1. It's going to become -2. It's doubled. E is at 2, 2. It's going to become 4, 4. Double. Double the length of FE. D is at 0, -2. It's going to become 0, -4. Doubled. I doubled it. So I have 1 rotation, 1 translation, 1 reflection, 1 dilation. 1 of each. Underneath here I have 2 random of those that you write the rule for. So these might be reflections, they might be rotations, they might be translations, or they might be dilations. So we're going to look at number 15. Notice that the orientation changed. That means it's either a reflection or a rotation. The size stayed the same. So it's not dilation. Because with dilation the size changes. But with translation, it stays the same orientation. So this is either a reflection or a rotation. Now we've got to figure out which one it is. So if I want to do a rotation, I'm going to spin the paper around and see if it is actually rotated. So I'm looking at this upside down. Well, I'm looking at upside down because it's moved 2 quadrants. It's moved 180. If it's only moved 1 quadrant, I would look at it just, like this. I'm looking at this, and I'm looking at this. And have they been rotated? Yes, they've been rotated, you see. Because when you have this one here, and you turn the paper upside down, this one becomes that one. And this one becomes that one. So which was the original? This one was the original. But does it matter? No, because it's a 180 rotation. If it was a 90, it would matter which way I went. But this is a 180. So it's a 180 rotation. 180 degree rotation. We are always going counterclockwise. But for the rotation, it wouldn't matter if I put counterclockwise there because it's a half turn. Alright, the next one, it changed size. This is obviously dilation then. The only one that changes size is dilation. The question is, by how much did it change size? Did it double? Did it half? Did it triple? So here's the original. Doesn't have the tick marks. This one is the copy. So this is the copy, or the image. This is the original. So I'm looking at this and it says -1 became -3. Because this is -1, 0, this is -3, 0. It tripled. Look at the Y. +1 became +1, 2, 3. It tripled. Look at X. 1, 1 became 3, 3. Tripled. So this is a dilation of 3 about the origin. We only did them about the origin, so it's going to be about the origin. So we didn't do about any other points but the origin. Alright, so on the back, same as last week, I'll make everything worth 8 out of 48, which I'll give you 2 free, so it'll be total 50 there on the back. And then on the front, everything will be worth 5, so out of 50 on the front. The main differences here on this week's test are these two. Symmetry, and these two, the dilations. Everything else we did last week. Good luck.